Thank you. I put on the lavalier mic because I like to wander around the room a little bit, so hopefully we won't get echoes. Before I start today, I wanted to get an idea of the audience that's in the room. I know what the global distribution of different tasks are, but how many people here are software developers or responsible for applications? Raise your hands. How many people are in the security team securing those applications? How many people are managing all those other people? And how many people are responsible for the overall security program at the company? Anyone here? Yep, okay. All right, so we got a good mixture of audiences. So just a little brief introduction to who I am and my background so we could get into some things here. I am going to allow some Q&A time at the end because I think it's really important to hear feedback between our peers and also to understand things that are happening in the industry itself. So my name is John Stuppiello. I am the Global Senior Director at Imperva, responsible for global application strategy. So with that, we work around the globe in different components. We have teams in Asia, EMEA, and North America focusing on different components of application security. So let's talk about API sprawl, but first of all, anyone that looked at the write-up for this session saw something like this. Before we get into the reason for API sprawl and how we're going to address it, we have to understand why we have it in the first place and the foundations so we can apply those later on when we get to the second half of our presentation, which is, so what do we do about what we've just heard? So two things that have been taking place. Most of us here have been for years. I know I've worked directly and indirectly in transformation projects, moving things, working on hybrid environments, working on getting systems into hybrid cloud environments many times. But then once we put them in there, what happens after 1 or 2 years? We do cost modeling and we start to realize without modernizing the application, it's not necessarily such a good deal as what we first thought. So we end up having to modernize the application to take care of the environment and also to go forward in the modern versions of mobile security and mobile applications itself. So these two work in parallel. The challenge we have when they work in parallel is that it creates a lot of security challenges. Okay. Is our AV guy here? Someone for the AV? Okay. Okay, so in 2023, we're seeing a constant movement and acceleration of these three areas. All of you have experienced it and are experiencing it at some point based on what you're doing in the company. The move from on-prem to multi-cloud has caused a tremendous amount of security opportunities and challenges, opportunities for bad actors, and challenges if we're part of the security team. Because we're moving boundaries, we're moving things around. We're taking responsibilities that used to belong into network teams, and some of those are moving into security teams. Some of the security efforts and some of the security budget is moving into the application ownership team, and the applications are beginning to police and secure some of their own components in addition to the security team. So this entire dichotomy has caused a whole slew of challenges, and our applications are moving. So as the applications have moved from monolithic into modern applications, modern microservice architectures, right? Think about that for a minute. If I'm a company, if I'm developing software, if I could create an API and consume my mobile applications, my web applications, and allow third-party feed of my applications, right? I've eliminated 2 development groups, right? And I can consolidate that. And we see that consolidation happening, and then those teams, those other people could be working on expanding out the APIs. So we're seeing that occur between application and API. But our databases are also exploding. Originally starting with concentric databases, on-prem databases, we're in a place now where databases are moving into a hybrid environment as well. Sometimes non-essential data is moving into data stores. It's moving into cloud data repositories. It's moving into subsections of that, right? And this combination of all three of these is producing some real challenge. The one we're going to focus on today is the one in the middle. As applications move to microservice architectures, as applications continue to expand out, what we see is the API consumption model. So I like to look at it this way, right? There are two different areas reaching into our private APIs. The first is external, and we're aware of a lot of these. These are protected by DDoS, abnormal attacks coming in and attacking our public APIs or directly in our public applications. And for years, we've all supported that and we've secured these. Anyone that has a web application has some sort of protection in front of it, whether it's a web application firewall or a combination of security products. There are a plethora of products there. But these are external attacks that are coming in. Bad bots are one we're going to be talking about, especially relating to APIs, because as the function and the role that I'm in, I see this traffic. I see the challenges that we have with these bots, not only doing good, but also attacking and trying to figure out the logic behind an API and an application. So we're going to get into that a little bit and then what we could do about that a little bit. So again, we're moving in to the public applications. Our data is structured, semi-structured, moving out. But then on the other side, we have our insider component. That's the box on the right here. Malicious attempts from the inside out. Careless developers or careless folks doing configurations. Compromised components or devices inside the company itself. Internal employees. Trusted partners, and trusted is in the infamous air quotes here, because there are times when trusted's not trusted the way we should be. This combination sets us up for almost a perfect storm when it comes to API attack. So if I'm a developer and I've been told that my monolithic app not only is going to microservice architecture, but now we're going to use APIs for everything and I'm going to consume those. So what am I going to do first? Are there a set of APIs I'm going to use? Are there a set of third-party APIs I'm going to begin to consume? Are there open APIs that have been sanctioned by the business that I could use? Am I going to write my own? Right? Or a combination of all those. And what happens when you do that? You're doing it many times in a vacuum. So if my developers over here are doing that, security team has no idea about that. Now remember, these APIs, other than maybe a firewall or a gateway, are fairly open. They're fairly open. So there has to be a combination and also a conglomeration of thought between these teams in order to really effectively deal with this, especially with the type of threats that I'm going to be talking about in a few minutes relating to APIs. So let's remember that our data is the subject of attack. The area and the vector of attack for my data is usually going to be the APIs of the application, because the data is going to be sitting there. So if I want to get to the data, I have to find a way to access the API and then pull that data back in my response, and bingo, I have the holy grail, especially if it's private data or sensitive data. So these are the two biggest blind spots. If you take away nothing else, remember today that you have to put your focus and your time from a security perspective on the security of the APIs and the data that they're addressing. We've seen many different approaches to this, and I deal with customers all over the world, many different approaches to this, and there are a slew of vendors out there and a room full of vendors and a lot of people that deal with these at all different levels. But the main takeaway here is that you need a comprehensive solution here. And it has to start at the program level. So if you're a manager and you have a security program that's been running for years, you have to start to begin to think about these additions to your security program, which could be 10 or 15 years old already, or maybe more in the process. APIs and data security. Here's an interesting stat. This came out of a report by Postman, who's very well known. Those that develop APIs know Postman. You probably use it. It's a tool that was always free. It's so old, I remember using it when I developed back in the day. But Postman's been around. It's been speaking of it. But look at these statistics. This is real stuff. These are real numbers, querying thousands of companies and thousands of folks. 46% of API developers conceive, implement, test, and deliver an API to production in 1 week. So out of that 1 week, how much thought goes into the business logic? How much thought goes into the security of that API? As much as you have time for, but then you have to deliver it, right? Have to get it out the door. We got to get the app moving forward. And then this one here, 38% of the developers that they queried, that's just 2023, have less than 2 years experience developing APIs. When I saw that stat, I was like, well, I went back and I checked the Postman report to make sure it wasn't a misprint, but yeah. And then last year, they do this report every year, and that number has been trickling down a little bit. Last year it was like 44% in 2022, now it's 38%. But what's the takeaway here? We're dealing with something that's so critical to our company's security, so important that it's carrying our private and our sensitive data back and forth between the database, the application, and to the end user, and yet it's being handled and developed by those that maybe don't have that background. So we need a way to be able to oversee this. We need a way to really drill in and understand this in detail. That's what we're going to talk about today. So I talked to leaders, to CISOs, to different folks around the globe, and I asked them, we get into conversations about a lot of things, but one of them is APIs. What are the most frequent challenges you have when it comes to the use of APIs for your business in the applications that are delivering the business to your customers? The first one, I really don't know what I don't know, right? I don't have the visibility I need. Now, we know there's a million tools out there. Everybody's selling an API scanner, something that could show the API flow. It's still not getting through. So this is the takeaway I want you to get. It's not just the tools. The process is very important here, especially if you're managing this. The unknown number of APIs and endpoints and resources across the enterprise are escalating. We have to make an assumption that these APIs that are being used, many of them we don't know about. Many of them we're not aware of, that there's a sprawl involved in these APIs. Somebody's developing something and they created a new private API and they didn't document it and they put it into the application. Now, I know that would never happen, but I've seen it happen at least 10 times that I could see this year, just among different places. APIs have a much larger attack surface. So think about what I just said. Think about this big attack surface. In the past, I only had one vector, port 80, or a secure port, 443, to go in and attack a web application. But now it's the Wild West. Now I can go in there and not only get through and try to scrape or do something with HTML, but now I have an API I could begin to learn. And if I could find a way to exploit that API, I could have it return the crown jewels to me. And that's a problem. And we've seen breach after breach. I'm not going to go into the list of breaches on the board. We've all read about them. We all know them. But there's a set of serious breaches out there that have taken place, and it comes through the APIs. If I could access that API and make it spit back the information I need, I just scan it all and then just disappear and go away, and I have the information captured. So that's why this is so important. My endpoints and all of the rest of these need to be covered. To make matters worse, before we get better and talk about this, these API attacks and the bad actors that are going after our APIs, this is not a manual process, right? This is automated, and it's intelligent, and it's taking place through bots. Now, in the past, we had bots scraping and dealing with our normal web applications, but now we have bots attacking, scanning, and more importantly now, with the advent of AI, trying to learn the business logic of an application by scanning and enumerating the application program interface over and over again in all different angles, with all different tries, all different properties, and all different components. If you can get through that, and if you could understand the business logic, you could wreak all sorts of havoc, but also harvest all sorts of information if you're a bad actor interested in this. So as a security practitioner, as a developer, I need to remember and keep top of mind a few things. I have to make an assumption that the API developed, first of all, has to be documented. Second of all, my documentation has to be consistent. I can't have last year's document and I totally changed all the properties of my new API, right? Now I know that would never happen, but I've seen that so many times. My God, it's amazing. Oh, our APIs are all up to date. Yeah, what about this? And then you go and do an audit. And It's like there's 1,000 new ones that nobody knows about. That's scary, right? Because every one of those 1,000 could be touching data, right? As a bad actor, I could pull the data back if I could get to that API. If I could break through some things we'll talk about in a minute. So I went internally and I started asking our security team about this. I said, I've talked to a lot of external customers and we all know about that, but internally, what have you guys noticed with different products, with different sources? All right? And I'm going to talk about this in a minute. How many people remember when SaaS applications started becoming popular? Anyone go back there, right? What was the first thing that the SaaS guy would come in and talk to you about? Do you know you have a shadow IT problem? You need a CASB solution, you needed this solution, you needed that solution, because how many services is your company using? And the answer would always be, well, we sanctioned about 60, so we have 60 SaaS services. And then when you go actually find out, all these strange services that are being run by some underground people in the marketing group and everything, you find out you have thousands of SaaS applications that the company's not only people running, but they're paying for, right? And you don't even know about those. As a security practitioner, this is a nightmare because you have no idea the security posture of those services, right? Well, this same problem now is back again, only now instead of the external user and the business, it's now the developers and the APIs. So instead of having a problem with shadow IT and Amazon, another popular one, or any of the other service provider accounts, right? There was a whole infrastructure built because people were creating their own shadow web accounts. And we know that would never, ever link to a production account, directly or indirectly, but I'm telling you, there's linkages, and they've happened, and they've caused breaches, and we've seen some infamous banks run into trouble with this, right? We can't have that. We can't have that. As a security professional, we have to shut that down somehow, or at least mitigate or minimize that landscape, because it's huge and growing. So I asked our guys, hey, there's this dilemma of, well, it's not my API. I don't know whose it is. I didn't develop it, but we're using it. Well, where'd it come from? Oh, I don't know, but is it secure? I don't know, We did a shadow API ratio over time. This is an old one in 2022, just to get an idea. And what we found when we finished all this, there were about 2,000 APIs that were unaccounted for. We had to go nail them down. Now, thankfully, they were all solid, but they were unaccounted for, meaning they weren't documented. We didn't have a security profile on them or on the vendor that produced them. And if they were an open API, we didn't know, from a programmatic point of view, we didn't have a system in place to know when the upgrades had to take place. We're all good at patching CVEs. We're all good at patching the operating system. We're all good at patching things. What if there's a blatant hole in the API? How do you track that? How do you know that there's a new version of the API that has to be incorporated into your applications? Is that part of your test cycle? Is it part of your build cycles? Is it part of your overall design cycle? Anyone working in the DevOps space here, right? Or the Sec space, is that part of the system? It's not just a matter of SAST and DAST. You also have to realize there's more analysis that has to be done at the API level. And that's why we see a lot of tools being generated. But remember, tools by themselves are not enough here. This is a programmatic change. This is a philosophical change. This is a mindset change that we have to understand from the top level down in order to be able to address this. Whether I'm in the developer community, whether or not I'm a leader in my company, whether or not I'm a security professional. Okay. Big problem here. Remember these four. I'm going to repeat these because these are important to understand. Number one, my APIs were never formally documented by the development team. I call it the write the documentation later phase. Hopefully we don't have any more of that. We usually see that in earlier, but remember, 2 years API developers, right? The longer you become in your skill and your craft, the more you realize I'm going to document it because I'm going to be covered. But the new guys, they want to blast it out there. They're cowboys of the API world, and they just go out there and they code away, and they'll document it later, and then later never comes. They go out on leave, something happens, they're on disability, and no one ever documents the API and ends up in production. Number two, the API was deprecated, but never removed. This is a bad one, right? Now, in code, we would never let code state an application that was deprecated, and I may put air quotes around this one too, but can be exploited by malware. But now this is a lot easier. I don't need malware right now. All I need is a bot and to figure out your API schema, and I can go in there and find a deprecated API that no one's kept up with, that's not secure, and go steal sensitive information or steal information with that API once I figure out how it works. Developers need to publish new APIs, but they don't document or inventory them. So you can publish it, but if you don't document it, and the publishing and the documenting solution you have as a company is not in sync, you're going to allow a hole in there, right? And this is what's happened. This is why we had industries back in the SaaS world like Casby when it came up, because someone needed a way to document the SaaS apps that were running. Well, we need a good way to document the API apps that are running and also understand internally and externally whether or not these are private APIs that are written by our company, whether or not these are vendor APIs, whether or not these are open APIs. Hence the term for the whole conversation, sprawl. Every week, there's a new vector, there's a new feed for APIs. And it's like, how are we going to control all of these, right? They get out of control. So developers, the last one, number 4, I know nobody would ever do this or has ever heard about this, but developers inadvertently exposing a private API to the internet. Do you know how many breaches have taken place with number 4 right there? They're doing a test cycle, and they have a test API that they put in there during the test, and somehow it gets into the change set and gets committed. Nobody knows about it, or no one uses it, so it's not a problem. But someday the bot finds it, because it's scanning everything, and it finds, oh, look at this. Look, I can get information out. I can enumerate. I can change the user ID, and it gives me everything I want. I don't have to authenticate again, because it was never supposed to be in there. It was a test API. Problem, problem, problem. Remember those 4? These are basic 101 level things, but I want to point them out to you. Right, so overall, we have these attacks here. The traditional attacks we spoke to already, right, we all know those, SQL injection, supply chain tests, misconfigurations. These are things we've dealt with for years, so I'm not going to spend time on them. The API-specific attacks we're going to talk about, and I want to spend some time talking about this last one, which occurs through APIs as well, and that's the business logic attack. If anything, this is the one I'm seeing causing a lot of challenge and a lot of nightmares for several folks, all right? We've gone through the problem that we've had. It's just new challenges to the same problem. API inventories, ask yourself the question, are they reliable? Can I trust them? If I can trust them, do I trust the posture of each of my APIs? Is it valid? Is it real? Is it keeping up with my development team? What about on the client side of things? APIs, traditionally, we like to design them so they're stateless. So where is the state stored if it's not in the API? Aha, right? That's the gotcha, right? I'm a bad actor. All right, I know the API has to be stateless. So where is the state stored? If it's on the client, I got to exploit the client. If it's somewhere else, if it's some sort of weird tokenization system, let me go look for that. Let me see if I can figure that out. Let's go put the bots to work to see if we could find that, right? And then exploit that. And then bad bots are targeting these private APIs because they're easy to parse. You know, in the old days, it was very hard to parse and scrape, you know, a web app that was old school web, right? Just HTML over HTTP. It was hard to do that because they were so different, so many differences, so many different frameworks. But now an API is so cleanly designed. It has a schema, for crying out loud. Wow. I don't even have to think of how to parse it. The parsing instructions are given to me. I just have to blast it and try different combinations to see if there's any challenges here, right? So private APIs, programmatic by design. Now bots. Now this is the only time I'm putting the company name in here because this is a free report that we released, right? The bad bot report. One of the things that we focus on as a company, and I focus on in my day-to-day, is how bots cause problems. And what we're seeing this year, I mean, they're also they have a good use too, but what I'm seeing this year, and what we've seen from 2022 to 2023, is the growth of bot attacks on APIs. We can look at API traffic, but when we look at the amount of API traffic that's generated by bot, it's staggering. Let me give you one example. I had one account I was looking at, 4 billion API calls per month, all right? Out of the 4 billion calls per month, 38% of the traffic was bot generated. Out of the 38% of bot traffic, we know from doing this a long time as a company and analyzing this, that 30% of all bot traffic is bad. So out of the 38% of the 4 billion, right, we have 38% of that, and then 30% of that are bad bot traffic, right? So there's an attack taking place, and we have to just protect against it, right? We've done this very well against web applications. Let's just make sure we're doing this with our APIs, all right? So this is the traditional approach, right? So these are our traditional components. We've also seen in the report, we're talking about the level of sophistication of the bots, from something that's just stupidly hammering away at something to try to find it out, to something that's very advanced, that's using an AI engine to try to determine the business logic of an application. And those are the ones that are becoming a bit of a challenge to really dig into, right? So we have to just plan for these. We have to prepare for them. We make the understanding and have the understanding that, yes, this is going to come our way the same way all these other attacks came our way, but we're going to defend against it the best we can. So how are we going to do that, right? Okay. First of all, we got to deal with this pain in the bot, all right? So how do bots target APIs? Here's two real examples from the last year, all right? The first one, API was built for an airline. This was a North American airline. They had an API that did flight searching. Another company decided they were going to be in the flight search business, but they didn't want to pay for it. So they figured out how to scrape the API for Airline A. Airline A was getting a $500,000 charge per month API calls from said cloud vendor. The other people were making money hand over fist, $0. This is the kind of stuff I'm talking about, right? Vulnerability in code and malware, we have to treat those. Those are table stakes at this point. But these kind of attacks are the ones we have to begin to figure out and work to protect against. The other one, North American Bank. This one was a little tricky one. So in this case, this was a login. There was a login API, right? All applications have a way to have a login mechanism. Now, they were protected against web application login. Now, there was an attack against them, 2 million account takeovers taking place every hour, all right? This is a real number here, right? So every hour, 2 million attempts to break into an account. But what they forgot, or what was not defended sufficiently enough, was the fact that there was also a mobile application. And the mobile application had a new API for logging in that wasn't documented as well as it should have been. And when they did the attack against the mobile application, it created the denial of service, even though the web was protected 100%. Because they didn't apply controls to the mobile application and the APIs, the login API associated with it, because they didn't know from an inventory perspective that there was an API change and the security team wasn't able to protect against it, right? It created a temporary denial of service attack to log in at all, right? Because at the end of the day, they're all going back to the same database and the same technology. So we realized, first thing we have to do is split these two. Secondly, we have to make sure anytime there's a change to the API that it's consistent. Now, what should have happened, right, is that the web app and the mobile app should have been using the same API and the same code, ideally, right? That's the way we would design this. But in this case, it wasn't quite there yet because, you know, legacy, when you have an app that's written for over 20 years, not that easy to just do that, right? We could say, oh, yeah, we'll just do it. No. We can't affect the business. We got money to make, right? We have to get the business running, so we have to be very careful, right, how we do that. Okay. Why is this so bad, right? Because in 2022, the end of 2022, we saw a 70% increase, and these are stats from the Bad Bot report, So in 2023, we summarized 2022 in our report, and then we showed what was happening up to the point the report was written. 70% increase in data breaches and a 40% increase in account takeovers versus the previous year with the same split of accounts globally. All right, so basically it's getting worse, right? And 35% of the account takeover accounts that we saw were targeting APIs and API calls. Right, so this is the change. The attack is moving and shifting to the API vector, right? So this is our big challenge. Across the different sectors, right, 37.8% financial services, telecom, this is just a breakdown, 2023, of what different services were affected by different account takeovers and who they're targeting, right? So obviously telecom and financial are big. Computing and IT internally was also big. I was surprised about this, right? So how many folks know about an organization called OWASP? Yeah? We all know OWASP, right? We've been around, good friends of ours. I know the folks actually at EMEA really well that run it. Had some drinks with them, and we chatted about this, and we started talking about what the new OWASP would look like. Right? So our OWASP released the API quadrant, right? A couple years back. But anyone that was really watching this and sensitive enough for this, a couple of months ago, they revised this, right? I did this last night. I was in my hotel. I went to OWASP's webpage and I checked this, and sure enough, number 6 and 7 are flipped, right? If you go look on the webpage, usually you see these in their order. This is their order. And they changed the name of number 6, right? They also changed the name down here of number 10. Right? They had something called acceleration. It's not there anymore. This is as of yesterday. Unrestricted access to sensitive business flows is number 6 for OWASP API. I'm going to talk about that in a second, what that is. These others are pretty well known to us. By the way, number 1 is still broken object level authorization. We're going to speak a lot of that in the second half because that's still the number 1 area of attack when we try to get into APIs, right? Try to compromise, break into the authentication phase and work our way through it, right? If we can get into the authentication, the next thing we do is try to look at the authorization piece, right? So that's where we have to really protect. But these were flipped. I noticed that, and I thought it was very interesting that this is moving up the chart. And also number 10 down here, unsafe consumption of APIs. That's an interesting one, right? So let's look at a couple of examples of this, all right? Unrestricted access to sensitive business flows, right? The API exploit is fairly easy, and it's a business-specific challenge to attack the API. Let me give you an example. Here's one scenario of this. There's many of these, but I'll give you one right off the bat. This would be interesting, right? An airline announced a promo. We're going to offer flights that have 100% return policy on them. Well, first of all, it's a business problem, right? But let's assume that it's not a business problem. Somebody got the idea and found a way, using the flight observation API, to create a legitimate account with a legitimate credit card, and they booked out the whole plane. 3 days before the flight, they canceled all the clouds. Automatically, the price of the tickets plummeted to nothing, and then they bought half of them back and resold them at a higher price, right? This is a business logic attack. This is what I'm talking about, right? These kind of things. How did that occur? It occurred because that API allowed it to occur, all right? That's the kind of thing we have to keep our eyes on. When you're working on an app, don't just assume someone's just going to try to come in and steal, a bank account number. It's a lot more sophisticated than that. They're interested in this, or an automobile manufacturer. They sell parts online, and they have an API, obviously, that does this. But the business logic was flawed in their application. So when you sign in in a formal account, you could order parts. So what happens if you order, let's say, 100 headlights? What happens to the inventory? Does it change at all? Well, it's questionable whether or not it should. But if it doesn't change, right, you're going to run out. You can't promise the person the time. So what somebody did was they created a set of bots. They went in and they ran the inventory down. This was a competitor. They ran the inventory down, did the purchase, canceled the funding source, and then people couldn't order the parts, so they went to number 2, which was them, and they bought from them, right? So they just shifted the business over using a bot attack on an API. This is the kind of attacks we're starting to see. These are the business logic attacks that are starting to rise up, and every industry has their own little unique niche. So we want to be sensitive to these. I want to focus on these in addition to the common ones that we all see. The common ones at this point I'm using as table stakes, but I'm going to talk about these in a minute, all right? Here's the second one, really fast. Unsafe consumption of APIs. There was somebody that created a, they created a Git repository. For those that know, Git, right, is a standard for storing the code. And they called it, right, basically they put in the SQL commands as the title of the Git repository to delete the database. Right? That was the title. And they had all these different fields and different names of the database, which were SQL commands. Right? And then they found a way, because their bot showed them the exploit that there was an opening in an API where it was an execution API, and if they just replaced it, it could use this. So what they did basically is they floated the Git information into the API, transferred it over to something else, and passed it to the database. Right? And they ended up causing havoc. I mean, legitimate thing, right? That's why OWASP is starting to sound the alarm on these, because we want to be able to take advantage of these. And remember, it's easy to get into the API and exploit. It's hard to do it, but they're business specific. So every business, you have to focus on your business logic, and the developers, the application owners, and the overall business management have to be in sync on the challenges, opportunities, and like everything else in security, what level of risk are we willing to take when we open these APIs up, and to what level are we going to open them? All right, let's keep that in mind. All right, business logic abuse is huge. We've talked about it a lot. Here's the reason why they're so bad, right? Number one, the APIs are mostly left to fend for themselves when it comes to authorization, right? If I'm using the API itself to authorize, and I'm not using a third party or an external source to do authorization, or authentication for that matter, I have a big problem here, right? If I could bypass or override the authorization mechanism, I can get in and I can start enumerating and doing things. Identity providers cannot stop an attacker that's leveraged because it's a fully authorized session with an authorized user from with a true, valid authentication token. There's nothing wrong with it, so there's no attack there. I can't stop this necessarily with schema validation, although it's very important and it does affect a couple of attacks, like the mass attack we'll talk about in a minute. But schema validation doesn't detect or stop API calls. It just lets us know whether or not something is correct or incorrect when the request comes in, and our response, whether or not it's formed correctly. And then outside services, right, often lack business context. Business context was never part of the equation, but now it's a standard. If we don't have the business, an API gateway doesn't understand business context. A load balancer doesn't understand that. It just knows I'm getting blasted. I'm going to do a volumetric slowdown here. I'm going to block it, right? But because of all of these things, we open to business logic attack, right? So let's go on. So what do we do about all this, right? What can we do? This could be an hour or 2 hour presentation by itself, but I want to give you a few highlights. And for the developer community here, you can appreciate this and take some notes here. It's not a matter of throwing product or buying gadgets necessarily to do this. I'm talking to those that run security programs right now. What matters is that the security program has these components in place, which may very well require us to add different products to do it. But the program is focusing on this. I have to, in my program, I must be able to discover, classify, and inventory my APIs accurately. I must be able to identify any implementation issues with my APIs, anything that's not solid or not right. You know, if we want to think about that for a minute, right? We have to know what it is before we can protect it, and we want to know the rate of change, right, implementation-wise, of our APIs to make sure we're controlling it. We want to be able to protect sensitive APIs. A lot of times the same API can be used for returning sensitive and non-sensitive data. Your APIs, are they bracketed? Are they separated? Are they segmented? You have an extra set of controls around those that are delivering sensitive information. Is there a defense in-depth strategy in place for the API security for those APIs that will be returning sensitive information, that are going to be tagged or tied to data that's tag sensitive? Very important. You know, in our business, we deal with app-end data, and what we see a lot of times, if data is tagged as sensitive or private, right, we know about that in the API call. So we know, hey, this is a privileged data API call. We want to make sure that we spend some extra attention on this, make sure that nobody goes into enumeration tasks, and we double and triple check the authentication and authorization of each of those calls. So it takes us a couple extra milliseconds. It's more than worth it for the security we're going to get out of it, right? And then obviously, you know, in our SOC, we're feeding this information, and we're going to monitor for abnormal behavior, but also every access to the API should be monitored. One of the things I've seen companies doing, and we've had some companies do this, is instead of just monitoring the traffic coming in and the API calls coming in, they put like an application self-protect component inside the application, which can see everything. It sees everything coming in, everything going out. It could tell if an API is malformed, right? And we've seen this. One example, you know, we put a component like this in applications. We have a couple of customers that were using this. When Log4j came along, they were unaffected by it. It did real-time blocking day zero because it knew that there's something wrong with the syntax in the call. So it just blocked it, right? And the next one that's going to come, right? There'll be another Log4j. I know there will. There's always something new that comes out. Unfortunately, I wish there wasn't. But there will be something else. Just make sure that you're doing defense in depth, that the application's being protected. The data, I know we do a pretty good job of protecting that. But that API feed is really important. If it's a API with private data, make sure, we all do this as professionals. We all have tags to make sure we know what's private and what's not, so we can audit it and control it, right? We need it for our audits, right? But at the same time, we need to cover this as well. PCI spec that came out, PCI 4.0, is starting to ask us for more and more information in this area. I had some folks asking us about a term we call cyber attribution. I want to be able to not only know, now as a database data professional now, I want to be able to not only know what API executed this query on my database, I want to know who the user was, right? How do we correlate that, right? Several different ways of doing it, but that's called cyber attribution and something that beginning to grow. We've had a lot of ask for it. We've been putting that in place. And there are probably a lot of other folks that are doing this, but it's just something that is going to help us get a better defense in depth posture on these challenges that are coming up, right? To be able to address these. All right, so let's go quickly through it. All right, how much time do we have here? Got a few minutes. All right, I'll go through these real quickly. Number one, every API must have a header assigned to it. Thou shalt not release APIs without formally documented or full headers, right? Not everybody does this. I've seen tons that don't have this, right? Make sure those are done. Secondly, if the header is in place, make sure that the request attached to the header and the body of the request is standardized, it's classified, and it's a repeatable type. Also that there's a schema that defines this. Don't let this run wild because it'll get enumerated and taken advantage of. The third one, a lot of times we overlook the most important piece, the response. The response is where we see our data coming back. And when we look at the response on an API, we can also tag which of these fields or properties is private information, right? And take advantage of those. Let's make sure our authentication mechanism is in place and it's solid. I didn't spend a lot of time on BOLA. That's a term that we could spend hours on. But basically, a break or a reuse in an authenticated session will allow us to switch it and pull data from somewhere else. Right? The infamous, we saw a problem with the infamous US Postal Service with this, where there was a flaw in an API. So once I logged into my account, if I changed the username to something else, I could pull all that person's information out from the postal database. Now they fixed it, but a lot of information, you know, the lettering, maybe not the actual letters themselves, but a log of what was delivered to them and all these things. Right? Very simple to exploit, very easy to protect, but we have to be aware of that. Mass assignment, incorrect assignment, this can be fixed with schema protection. Make sure that when you're doing API security, you have something that's controlling and monitoring the schema. Also make sure when you're doing your testing at runtime, your SAST and your DAST, that when APIs are involved, you're making sure there's no change or fluctuation from the original schema and the data that's in there as well, okay? And then lastly, your sensitive APIs, there are two types, right? So stateless API is a single request. I shoot it, I block it when it comes back. These are real-time requests. When we see something like this, a CVE or a COTS type vulnerability, right, which is very common, we block this in real time, right? This is something we do, and other tools do this as well. This is not something we think about, it's just blocked immediately. But with business logic attacks, sometimes it takes hundreds of thousands of access requests, right, to do a stateful attack on an application through an API. And these are the ones we're talking about, a business logic attack, physical inventory attacks, sensitive data harvesting, right? And as we look at OWASP, we can see that they've covered these pretty well. Go back and review it again, especially go back and look at the change they made. I think they called it version 2 of their API. It's just there, right? And then lastly, our mitigation techniques, right? There are a lot of these we've put in place. Not going to spend the time to go into all of these in detail here. Some of the things happening in the world of BOLA that we just talked about, where the object level authorization gets broken, is we're beginning to see tools come on the scene now that start to automate this and help us to solve this problem. In the past, this was wide open. You couldn't really protect adequately. And there's no silver bullet, by the way. Anyone that says they have a solution that could solve 100% BOLA, you know, I want to meet them, all right? I got to talk to that person because it's not true, but you can get much better, right? And using some advanced technologies, you can detect endpoint parameters that are susceptible to enumeration. And then you look at the context to determine if they're valid or not. Remember, this is a context thing, which means I have to know how the application works. I have to know what I'm trying to do, right? That's very hard to automate. So somebody's got to oversee this, right? Until AI gets to that point, which, you know, none of us will be here, and I don't know, you know, some year, not first. And then lastly, when you're designing your applications, my last slide, when you're designing your applications, build to proven architectures, right? We've done this for years with web applications. We use architectures and frameworks when we're designing. Well, API is starting to enumerate now. This is one example. It's called a neo-security architecture. So a vendor has that out. But one of the things here is it's built on standards, right? Identity management, the authentication is built on the standard. The federation is built on a standard. User is built on a standard. Same with tokenization and all of these pieces. I thought it was interesting to see entitlement management coming back. It's something that I've seen years ago coming back again to centrally manage an application authorization. So again, all of these standards are in place. And then finally, I saw a vendor come out with this. This was interesting. They proposed what they call the API security maturity model, right? I thought this was interesting. This is, right? Basic authentication, token-based authentication, and whether or not it's token-based authorization, and then finally centralizing the model using claims, right? For those that are familiar with APIs, you know what a claim is, right? Centralize it, right? It gives you total control over everything that's going back and forth, every request for authentication, authorization, and applying a claim. So remember these things as you go forward. APIs are the new attack ground. They've been, but they're becoming the standard for attack. We see more attacks occurring on APIs now than we're seeing in traditional web applications, which we have pretty controlled right now. We can block those really well. Remember that business logic attacks, such as the ones I gave you, are prevalent. Review your business logic. Review what the developers are exposing via API. Make sure your API inventory is accurate, it's thorough, and it's up to date. Or you're going to end up on one of my slides in the next person. No, but just make sure it's accurate, right? Because these things happen, and it's so complicated what we do. It's easy to overlook these, right? So we want to control these and make sure they're part of our program. They can't just be ad hoc. All right. At this point, we're just about at the end of our session. I think it's time-wise, yeah, just about at the end of our session here. Were there any questions? Otherwise, we're finished up because I know I'm holding everybody from lunch. Yes?
Mm-hmm.
Yeah.
was about improving response time, right?
Mm-hmm.
So in light of, like, again, security, have you seen, what is your experience, I guess, when it comes to balancing security control, but also still achieving desired improved response time?
Right. So, and this is the challenge we've always had, right? The power of the business versus the response time of the application. It comes down to risk, right? How much risk are we willing to allow, right, or consume? In this time, sub-perception is the ideal if we can get it. If we can't, it's better to err on the side of going a little slower and making sure we have it protected thoroughly, but then work on a way to fix it. I can't give a discrete number. It's not really an objective. It's a subjective thing, right? So I don't have an objective number, but we try to make it so it's subvisible, right? Or it's not perceptive, beyond perception. Any other questions? All right. Well, thank you for your time. And, oh, one more in the back. Yes, sir. Mm-hmm. Yeah, yeah. There are tools to do that, absolutely. Yep. You can definitely talk about that. Yep. We do that all the time. There are ways you can monitor everything coming in and out, and you can see all the API calls and everything like that. Right? And then you can just go to a portal and see it. Right? It'll even show you the attack vectors associated with them. Right? So, yep, the tools available today to do that. All right? All right, thank you all for your time. Enjoy your lunch. Have a great day.